errors in the procedure because we critically think, and we have corrected these errors. Now, what we are proving, what are we verifying? What's the aim of the experiment? We are verifying the law of reflection. We are verifying that incident ray and the reflected ray form equal angles at the mirror. And we already know what is reflection. Reflection, this is where the light strikes the reflective object or material or the mirror and is reflected, meaning is traveling a different direction or and a different angle from that material, away from that material. Now, there's a bit of difference between reflection and refraction. Refraction we're going to discuss in part B, not part 2. Now, part A is here. This is the front of your page. And we're going to follow the procedure to verify this law. Or we're going to verify that two angles of incident and the reflection are equal. All right, so the first step is to set up the equipment. We have set up the equipment. Equipment is working. I am going to do, first of all, in this step number 1, is going to mark the position of the back of the mirror. I'm going to turn off the equipment. We don't need it yet. Now, the mirror that we have has got a front part and the back. The back is important. And this part is mentioned in the procedure because this part, the back, consists of silver iron. And the silver is reflective. So it reflects the light. So we are interested at the back of the mirror. This is the working part. This is the part that actually reflects. So we're going to mark it on the mirror. And how? How are we going to put the mirror? This way or that way or that way? We're going to see if we can see the reflection. The reflection is happening. I don't know if you can see. I'm going to turn off the light. Okay, so I've dimmed the light so we can see the reflection. This is the reflection is happening. The reflection is, we can change the direction of the incident light. We can change the direction of the mirror. It doesn't really matter. We can see the reflection. The light comes in through the light box through a single slit slide. We inserted here. So this is the ray that is produced. Is reflected by the mirror. See, we rotate the mirror. Okay. So this is the reflection. So we are going to turn off the equipment. It's okay, we don't really need it. We have understood that the position of the mirror needs to be somewhere on the front, somewhere on the front so that the ray will be reflected from the mirror. Not here, we can't position there, we can't position there, somewhere here. So we will trace the back of the mirror and we can ensure, see, any angle. But the front mirror needs to face the front of the light box. So we can mark the back of the mirror here and here with 2 dots. We need two dots, 2 points by the geometry law to draw a line at least 2 points. I can demonstrate that later to draw the line. So we are drawing red line, and this is going to be a line called back of the mirror, but I'm going to put M for simplicity. Just to demonstrate that we can't draw the line for 1 point, we can use a piece of paper and we can draw the line, but the direction of the line would differ. So when we have 2 points, we draw the line for 2 points, and it's got the direction. So we need 2 points to draw the line with the correct direction. Now, doesn't matter that we turn the equipment or we move the light bulbs or we made a bit of mess, it's okay. We determined where the back of the mirror is going to be. We're going to place the back of the mirror there, right? And we're going to direct the light. So we've got incident ray coming from the box and the reflected ray, right? Great. So don't be afraid to make a mess. Move things around, it doesn't matter. In science, we critically think. I'm going to turn this off, put the mirror away, and I am going to follow the instructions further, and I'm going to mark the normal line. So what's the normal line? The normal line is a line at the 90 degrees to the mirror, right? At the point of which the incident ray strikes the mirror. So the incident ray strikes here the mirror, and the reflected ray comes out of that incident point. So we are going to draw the normal line from the point on the red line where the incident ray strikes the mirror. Again, we can turn off the equipment, mess around, you know. We can come back to that. In science, we can always work from the end to the beginning or from the beginning to the end logically. Okay, so first of all, by definition, normal line is perpendicular, as I just explained, to the mirror or the back of the mirror. So it doesn't matter where we're going to draw this line, at the center or off center. We have determined we can always manipulate or move our equipment, right? Later on, to make this line normal by striking the light into it. So I'm going to make my normal. I'm going to put that paper like that just because I like it. I can always change things around and play and experiment. This is what science is about. Don't be afraid to make mistakes. Okay, so we are going to make a normal at 90 degrees. So again, we're going to place the dot here on a lower scale and write the dot opposite 90 degrees on the upper scale. So again, do you remember you need two points or dots to draw the line in the given direction. This is law of geometry. We are joining these lines and I'm going to join them in blue color. And I'm going to mark it as N for normal. This angle is 90 degrees. This square means 90. Now, an interesting part is to place the mirror where the mirror is, strike the light. Okay, let's just manipulate things around and play. Strike the light at the normal, right? At this point. So this point is point of incidence. I'm going to write I for incidence, right? So strike in the mirror. And this is at this point, the light is reflected. Well done. Now, can you see how the rays are thick? Okay, I'm going to trace these rays like that to show how thick they are. And they are not even in their thickness. You can see that here it's about, the thickness of this ray is about 1 millimeter. Here maybe thicker, here's 2, here 2. So that is what we note. We note things, we observe things. We're going to put 2 points, doesn't matter, in the middle of the ray or near to the outline. We are just noticing where the source of the errors could be, because we're striking for accuracy when we prove our laws and signs. All right, so we can turn off the equipment for a while. And we can now draw the line through these 2 dots on 2 points, and you can see that, you know, there are a bit of a inaccuracy in drawing this line because the ray was quite thick, and you know, we use a pencil with a different sharpness, different thickness of the, you know, point, and this is all contributes to this a small, you know, error in the line drawing. Now we have to mark the errors to show which ray is incident with the error like that and reflected. So this error is incident and error like that is reflected. I will also use orange color to draw these lines so that we can distinguish between mirror, normal, and ray. Oops. Someone needs to have a drawing lesson. Now, we can see the reflected and incident rays clearly, and we're going to be measuring the angles. Angle of incidence. So the angle of incidence is in between normal and the ray of incidence. So this is angle of incidence. And this is angle of reflection. And this is it between normal and the reflected line. I'm going to turn on the light because it's a bit dark for me. Okay, so this is better, and I've also decided to record it a bit closer so that we can see the degrees that we're going to measure. Okay, so we're going to measure this angle between normal and the incident ray. It's called angle of incidence. We're going to place a protractor. We use protractor to measure angles, and we're going to place the protractor on the mirror line, the back of the mirror to be precise. Now we are going to put the place where the hole is, or the middle of the lower scale, at the point of the angle, and make sure that this line, the black line, sits on the normal line. And now we are going to note the position of incident ray on the scale. We are going to use this scale, the upper scale, to measure the angle coming from lower to the higher number over there. So we measure the angle to be around, exactly 45 degrees. So this is degrees of the angle. Before we forget, we have to write it down here in our results table. Ray 1 against the ray Y. Ray 1. What is ray 1? Ray 1 in single quotation marks is this setup. This is one ray that we've directed and reflected. That's all what it means. But we call it ray 1. In our procedure, it says label this ray 1, cross this ray 1, and say label this diagram ray 1, or set up as a ray 1, right? We don't label the ray, we would label the diagram. And this setup is on the table, ray 1. Okay, so we've just measured also the angle of incidence as I have shown you, and we know that it's 45 degrees, right? We double check. I like to double check everything, because when you double check, it means you can find errors by checking it. If you triple check, pretty much result is going to be 100% accurate. So we double check. We place the protractor as I've explained. We see where the red line sits on the upper scale of the protractor, we read the reading as 45. Okay, now we have to write it here, as I said. So this setup is ray 1. Angle of incidence is 45. We are going to measure now the angle of reflection. And we're going to do the same thing as what we did, exactly the same thing as what we did with angle of incidence. So this is the reflected ray and this is normal line. So we're going to measure the angle of reflection, as I've said, placing the center of the lower scale on the mirror line, which is here, red, and we're going to note where the red line corresponding to the reflected light strikes the scale, the inner scale. So we can see that the red line strikes the lower scale at around 45. We can check the upper scale above the inner, and I would say it's around 46 or 45. Can double check. No, 45. 45 degrees. I am going to place it now like that, and I'm going to show you closer. Okay, this is a camera action. Right. So, we're going to write this number in the table. We're going to write 45 degrees. This is against the angle of reflection, and that was against the angle of incidence, and it's against the ray 1 diagram, right? Here, I also want to tell you something that I've corrected in step number 2. Do you remember how we found this point? We didn't measure a center, we just sort of manipulated the light towards it and the mirror, and we drew the normal at any point. So you have to cross this is really incorrect, and you have to change it to on an angle towards point of incidence, or as I have shown you, or, sorry for interruption, the camera issue. So as I have explained, so this is not correct. That was a point of incidence, which is at any place on the line, on the mirror line, and I will show you more of that. So that is not correct. Label this diagram as ray 1. It wasn't very clear, very confusing, and I don't blame you kids when you can't do your work really properly. And we have filled in angle of incidence and angle of reflection against the ray 1. Now we have proven the law of reflection, where The angle of incidence equals the angles of reflection equals 45 degrees